Alright, this is week number 4, Monday the 17th. NET-200, Introduction Networking. We reviewed some packet tracer. 3 files should be turned in. The actual packet tracer, the PDF, and then a PDF document with the results. Make sure you fill in the comments. Remember, the object is to learn and not just get the task done. We reviewed some things. I clarified WANs and LANs, topologies. We talked about physical and logical topology today. Services. What services do we get from networks? Well, we get web services and the ability to transfer files and so forth. Labs, workstation connections. We talked a little bit about IP addressing today, connections between the switches, and configure V2I access. We're actually going to have to do that on Friday. Students had the labs up and working. Okay, so come Friday we're going to talk about protocols and communications, and then we'll continue some of this lab work. So, local area network. It's in one local area, typically within one company. More or less one company is managing the LAN. It's under the supervision or the control of a particular company. WANs are usually over a larger geographical area and need a service provider. Now, for an example, here at NIAC, we can have Charles City. We have NIAC here in Mason City. We have our own LAN here. Jim Deegan and a number of other IT people manage that LAN, connecting the dorms and all the buildings and so forth here on campus. Now we have a site in Charles City, and those two sites between NIAC and Charles City, they can actually look like one network using the internet and a VPN. Using a virtual private network. It doesn't actually connect the two. Your ISPs allow you into the internet, and then it switches the packets through the internet. They don't all have to go the same way, but they're all encrypted when they leave here, and they decrypt them when they get over here. So they're secure in going through the internet. Most virtual private networks do that, even though they wouldn't have to. Okay? So, when you could go through a network, or you could go through a service provider. Could connect your networks together. Okay? Typically pay for them either by data or by bandwidth. So many bytes or so many bits per second. Okay. Talk about topologies. Logical topology is what we typically draw here, and then we looked at a physical topology, the actual connections from, let's say, the PC, the wires that connect to maybe a port in the wall, and then the wire that goes to a patch panel. The patch panel has patch cables that connect to a switch, and so forth. Physical compared to what we draw up here, really a logical network. Alright, now we're going to look at the addressing. Part of the address is the network, and part of it's the host. I wrote down this public address that we use to access that work server number 2. Each one of these numbers is represented by 8 bits, which gives us 256 combinations. So counting 0, we can have a number 0 to 255. You would never see an IP address, any of these octets, over 255. And then we split it. Part of it's the host and part of it's the network. The host is on this side and the network's on this side. So we looked at an example when we looked at the PCs. In order for them to communicate, they have to be on the same network part. So that would have to look the same, and then they'd have a separate host number. That would look different from PC to PC. So, Friday we'll continue. Well, you should read Protocols and Communications, and we'll take a look at that on Friday. That's it.